Yes. Now let's start. Today we will give some basic definition and properties about the matrices. First of all, let's give the definition of the matrix. What is the matrix? And it take the any matrix. For example, A is a matrix here. A is a matrix. M by N matrix. A is a rectangular array, M and real numbers. It's okay. So what's the M and here? M and integers. It's okay. Integers. If our matrix has, and this one is first row, and next one second row, and then the row I is okay. Row I, and this one is the last row, and these and the matrix, this matrix contains m rows, and means that the number of rows is n. It's okay. And also, and here, and our matrix contains n columns. This one is the first columns, this one is second column. It's okay. This one is the column J, and this one is the last column. It's okay. So what's the number of columns? 1, 2, 3, and so, and the last column. And so the number of column, the number of columns n. It's okay. So A is m by n matrix. This matrix also denoted by this notation: A bracket A sub ij. It's okay. And means, and this one is A, and capital A is a matrix, and these A entries. It's okay. So look at the matrix A here, and this one is called row I. This one is called the column J. It's okay, column J. And sometimes the m is equal n. It's okay, the same integer. So and also, and this one is the m and a are called the dimension, row and column dimension of matrix. It's okay. So what is the dimension of these matrix? Mn. It's okay. So sometimes m is equal n. It's okay. So, and this matrix is called square matrix. Square matrix. It's okay. And also look at the, let's come back our matrix. It's okay. And the second row, A sub 2, 1, sorry, 2, 2, and so on, 2n. And look at the, and this one. But first of all, sorry, and our matrix is square matrix. Our matrix is, assume that our matrix square matrix. So this one should be n1, n2, nj, n. It's okay. So this matrix n by n square matrix. So look at the, and these entries. It's okay. These entries. So, and this entry, first entry, A sub 1, 1, and the next one, A sub 2, 2. Next one will be A sub 3, 3, and the last one, A sub n. And these entries are called the main diagonal. It's okay. And this one is called, it's okay. This one is called the main diagonal of A. It's okay. Main diagonal entries A sub 1, 1, A sub 2, 2, A sub n. It's okay. And this one is called the entry, and this entry and is noted by and bracket ij entry. It's okay. ij entry of matrix A. First of all, look at the this and ij entry means, and these entry in the row I and row J. It's okay, row J, located in the row I and the row J. First, for example, and they take this one, A sub 1 3. This one is entry of A, but this entry located.
Hocam mikrofonunuz kapandı.
Arkadaşlar,
Yine kapalı hocam.
arkadaşlar bir şey söyleyeyim. Lütfen benim dışımda başkası mikrofonlara falan müdahale etmesin. Çünkü kapatılmış oluyor, fark edemiyoruz. Tamam? Duyuyor musunuz sesimi?
Evet hocam.
Evet.
Tamam, devam edelim. Let's give example. And the first example, for example, look at the first matrix, matrix A. It's okay. This matrix, what can you say about this matrix? This matrix contains two rows, and so the dimension 2y, and what's the number of columns? First, second one, third one, and the last one, 4. So, and our matrix A is 2 by 4 matrix. It's okay. And also, these matrix, square matrix or not square matrix, because and the number of rows 2 and the columns 4. 2 is not 4, not square matrix. And also, and here, let's come back. Our entries here is okay, of matrix A, real numbers or complex numbers. It's okay for all ij in, let's write here, ij in real number or complex numbers. It's okay, but and in our lecture, it's okay. Consider the matrices and the all entries in, and the all entries are real number. It's okay. So let's come back. Look at the matrix B, C, and D. It's okay. So, and we can say that A is 4 by and a 2 by 4 matrix. And the first entry, what's this one? A sub 1, 2. A sub 1, 2 means look at the first row, second column. First row, second column, this one. So entries in 1. So this one is, and the first row, second column. So, and 2, sorry. First row, second column is 0. It's okay, is 0. And look at this one, A sub 2, 1. What does it mean? Look at the second row, first column, and this one, 2. A 2, 1, 2, but A 1, 2 is 0. It's okay. Be careful. Order, it is important. So, and look at this one, for example, and look at second row, third column. This one. The last one, for example, 2, 4, 2, 4, this one. It's okay. So, and consider the all and the matrices here. So what can you say about these matrices? And look at the first one, 2 by 4 matrix. And with entries, some entries, is okay. And B, sorry, B is a matrix. And what is the dimension of B? And contains one rows and the two columns. One rows, two columns. So 1 by 2 matrix with and it contains and only two entries B sub 1 1 1 B sub 1 2 2, and this matrix B is noted by this notation Bij. It's okay, Bij. So B sub 1 1 B sub 1 2 2. And look at the next example, C. It's okay, C. What's the dimension? And so for 1 by 1, because contains only one rows, one columns, so C and has only one entry, and this entry 5. And so what's the notation? And the C is noted by Cij, so only contains and only one entry, C11 is 5. It's okay. Look at the last and matrix and the D. What's the dimension? 3 by contains 3 row, so D is 3 by 1 matrix. It's okay. 3 by 1 matrix, and so for example D11 1 here, D11 1, and so D21 0 and 31 3. It's okay. And also this and the last matrix, special matrix, because contains only one column. If our matrix contains only one column, look at the last example, D contains only one column. So this matrix is called vector. It's a called vector. It's okay. And also sometimes and our matrix contains only one row. Look at the B contains only one row, and this one is also called and a vector. And so but and the B is, what's the dimension? 1 by 2 contains only one row. B is a vector, so this vector is noted by 2 vector. 2 vector. What does it mean? Contains only one row but 2 column. D contains only one column, so is a vector. So this vector is noted by this notation is called and the 3 vector, and means contains only 3 row. It's okay. For example, the next one, look at the A. A is a square matrix. It's okay because contains and the 3 and dimension 3 by 3, contains 3 rows and 3 columns, square matrix. And what's the diagonal? The main diagonal, this one is called main diagonal. Let's write the only main diagonal entries. It's okay. And 1, 3, minus 2. It's okay. The main diagonal entries. And this one and this one form the main diagonal of matrix A. It's okay. And this one is, we know, if our matrix is 1 by n, and n by 1 matrix, and means contains only one rows, only one column. So this one is called an n vector. It's okay. N vector because contains n columns or rows. It's okay. So, and look at the next example. U, and this one is a matrix and also vector and a 4 vector. And this one is a vector, 3 vector. It's okay. And also, some matrix contains the zero entry. It's okay. For example, look at this one. And you have to write then the zero entry. And this one is, for example, let's omit the zero and write this one. And the u is 1, 2, minus 1. This one it is not true because dimension is 3. It's okay. And here and it contains 3 columns. But this one is a matrix contains 4 columns. It's okay. Don't ignore the zero entries. You have to write. It's okay because dimension it is important for matrices. And let's give then the definition of the diagonal matrix. Diagonal matrix. It's okay. What's the diagonal matrix? And they take the matrix, but these matrix, first of all, and it should be square matrix. Our matrix A, and they assume that these matrix square matrix, and means the number of rows is equal to number of columns. Is okay? And if the ij entry for all I, but I is not j, then A is diagonal matrix. What does it mean under this one? And the R matrix, square matrix, and means, for example, take the n by n matrix. N by n matrix, write an R matrix. So if R matrix and the square matrix, yes, and the diagonal should be diagonal, and means, look at the definition. If A is not J, our entry should be 0. What does it mean? And the first entry A sub 1, 1. The second one, and the A sub 1, 2. 1, and the A is not J. 1 is not 2. So, and the distance should be 0. So, this one should be 0. And the next one should be 0 and 0. And the next one, next row, 0. A sub 2, 2. And the next one, 0. And 0, 0. And the last row, 0, 0, 0, and the last entry A sub and N. Look at then the R matrix. R matrix is a square matrix because contains n rows and n columns. Look at so it is possible to mention the main diagonal entries. Otherwise, let's come back. The first matrix is not diagonal matrix because n by n, it is not possible to mention the diagonal entries. Is okay? Because this one is not square matrix. Yes, let's come back our definition. It's okay. Sorry, this one. And R matrix square, look at this part, main diagonal of the R matrix. So main diagonal entries. Look at this part. Let's use a different color. Will be better. Look at this part. Look at this part. And this part is 0. This part is 0. So our matrix is in this form. What's the form? And here and this one. A is A sub 1, 1, 2, 2, and A sub n, n. This part is 0. This part is 0. This one. So our matrix is in this form. This one. It's okay. Yes. Any question? No. Okay.
Hocam benim bir sorum vardı da.
Okay.
Birkaç önceki sayfalarda sadece C eşittir 5 diye bir matris vardı. O matrise square matrix diyebilir miyiz?
Evet. Tanımı sağlıyor çünkü değil mi? What's the
Anladım.
definition of the square matrix? Square matrix means what's the dimension? 1 by 1. The number of rows 1, the number of columns 1. And look at then the definition of the square matrix. If M is equal N, is called square matrix.
Peki square matrixlerde hiçbir şekilde vektörden bahsedilmiyor mu mesela?
Bu aslında neye karşılık gelir? Bu neye karşılık gelir? Bu aslında
One vektör.
Reel sayılara karşılık gelir. Öyle değil mi?
Evet.
And this one is take the matrices, and matrices is denoted by denoted by M, capital M, and for example, and they take the n by n matrix, square matrix, and entry is real number. It's okay, and means this one is a set. This one is a set, contains all matrices dimension n by n, and this one is, and for example, take the n matrix, and for example, here it's okay. For example, take this one. It's okay. Maps to 5. It's okay. So 1 by 1 matrices correspond to the real numbers. It's okay. Contains only one, this one. But and here the critical point here, notation, it is important. It's okay. Notation, it is important. This one is 5, real number. It's okay. But this one is a matrix, contains only one entry. But it is possible to write these math one-to-one matrices corresponding to the real numbers. It's okay?
Tamam
Yeah.
hocam.
Yes. Any question? Other question? Okay, let's come back here, and let's and here is a diagonal matrix, and also, and take the any diagonal matrix. A is a diagonal matrix, it's okay, and the right, and this one diagonal b1 b2 bn, and if a sub 1 1, a sub 1 1 b1, a sub 2 2 b2, and the last a sub n n bn, it's okay. So this one is b1, b2, bn are diagonal entries of matrix A. It's okay. So, and a diagonal matrix should be square, yes, n by n matrix, this one. And this one is diagonal, and means these parts 0, these parts 0. It's okay, this part 0. So, and this matrix is denoted by this notation, diagonal b1, b2, bn. What does it mean under this one? This one means this matrix. It's okay, this matrix. So, for example, look at then the first example. What can you say about the first and the matrix? It's okay, first matrix. And let's use a different color, will be better. Yes. Look at this one. And this matrix, square matrix, yes. And what's the dimension? Because 4 by 4 matrix, square matrix. This one is diagonal matrix, yes. What's the reason? This one is diagonal entries, and these parts 0, these parts 0. Yes, this one is diagonal matrix. It's okay. So, and this matrix is denoted by this notation. It's okay. Use, and we can write diagonal. So write the entries -1, -1, and 1. The next one 1, and 0 2, 0 2. Look at this one. It's okay. And so, and this and this one is, look at this second part and this one. It's okay only. What does it mean? And First one, second one, third one, 4. And means this one is diagonal, so this one is 4 by 4 matrix, and the first entry will be -1, the second one 1, and this one is 0 and 2. So it's okay, this one. If, for example, look at the write this one. 0 contains 0 entry, yes. Write this one. Diagonal, diagonal, -1, 1, 2. Omit 0. So, and the natural question, and this matrix, the last matrix, and sorry, this matrix is equal this one or not? Not. Because what is the reason? And this one gives 3 by 3 diagonal matrix, but this one gives 4 by 4 matrix. So, and this matrix is, use a different color. Yes, our matrix, this one is this one, -1, 1, 2, 0, 0, 0, 0, 0, 0. Look at this matrix, 3 by 3, but this one is 4 by 4. Not omit. It's okay. And also, for example, look at this one. This one is another matrix B. It's okay. Another matrix B. For example, take this one, diagonal, 1, -1, 2. This matrix is equal to matrix B or not? Not. Dimension, this one is dimension 3 by 3. 3 by 3. So, and the matrix B, 3 by 3. Yes, dimension the same. But, and what is the, and this one? For example, this one is C. It's okay, C, matrix C. What's the matrix C? C is 1, 0, 0, -1, 2, 0, 0, 0, 0. This matrix C is not B. What's the reason? Because first entry of C is okay. 1, 1 entry 1, but this one is -1. 1 is not -1. So C, matrix C is not the dimension, and the C and D have the same dimension, row and column dimension, 3 by 3, but not equal matrix. It's okay. So what does it mean? And order of the entries, it is important. It's okay, important. Be careful. Don't omit 0, and order it is important. And also it's okay. Any question? No. Okay.
Hocam her square matrix'e diagonal matrix diyebilir miyiz?
It is not possible because what is the reason? Look at this one and the matrix A, square, diagonal, not diagonal, because this one is not 0, not 0. It's okay.
Teşekkürler hocam.
You're welcome. Let's come back. Look at the next example. Look at this one. Second one. Use a different color. This one. This one is a matrix. What's the dimension? Dimension 2 by 2. 2 by 2. And means, and this one is square matrix. Yes. Diagonal matrix or not? Yes, diagonal matrix. What is the reason? Because this one is the main diagonal, and the first part and this part should be 0. Yes, this part should be 0. Yes, and they satisfy the definition of the diagonal matrix. A different from J, and this entry should be 0. Look at our matrix. This one is 0, this one is 0. Yes. But, and also here, main diagonal entry is 0. But look at then the definition. Let's come back. If A is J, and we don't know this entry A sub A, only real numbers. It's okay? And this real number may be 0, maybe not. It's okay? And our condition here, A is different from J, our entry should be 0. If A is J and real number, it's okay? So let's come back here. So this one is a diagonal matrix and also square matrix and also diagonal matrix. It's okay? So look at the next, and so what can use this notation? Diagonal 0, 0. Look at the, and first of all, look at this part, and means, and this one should be 2 by 2 matrix, and the main diagonal entry is 0, 0, 0, 0. And so what's then this one? This entry should be 0, this entry should be 0, so we obtain our matrix. Is okay? So look at the next matrix. This one. So square matrix, yes, 3 by 3, because the number of rows 3 and the columns 3, the number of columns. So square matrix, and also these parts 0, these parts 0, yes, diagonal, and the matrix. And use the notation, and this one is denoted by this one, because main diagonal entries, and the first one 1, the second one 1, 1, this one. We obtained under this one. That's okay. But first of all, and for example, and look at this one, diagonal 1, 1. This one is not equal this one, because 1, 1. Sorry. This one is 2 by 2 matrix, and this matrix is denoted by, and this one. It's okay. This one. This matrix is not equal this one, because and our matrices have the different and the row and column dimension. 2 by this one is 2 by 2. This one is 3 by 3. It's okay. And now let's define the new and the specific and the matrix and scalar matrix. What does it mean, scalar matrix? You know, and the definition of the scalar matrix? Any idea? Yes. You know, and the scalar matrix.
1 by n matrix, maybe.
1 by?
Any number.
And it contains only one row. So one row. It's okay. And
Yes.
look at this one. 1, 2, contains and 3, for example. And this one is scalar matrix.
No. I think
Contains,
so.
contains only one row, but it is not scalar matrix. This one is square matrix. No. So, and the scalar matrix should be square matrix first of all. It's okay. And also should be diagonal matrix. It's okay. So, and let's define the scalar matrix. It's okay. Take the n matrix A. It's okay. Sorry. Yes. And take this one is important, diagonal matrix, and means our matrix should be square, and also these parts 0, these parts 0, diagonal. It's okay. And also look at the main diagonal entries. If main diagonal entries, how to represent the main diagonal entries? if A is equal J, and this entry should be C. C is the real number and scalar. It's okay. And the fixed number C. And the A is different from J, should be 0, and the main diagonal. So look at then this one. It's okay. C and not C, and take the B here, scalar. And so, and this one is first entry will be B. The second, this one is B, B. All entries on the main diagonal should be B, scalar. It's okay. B is a real number. So this part 0, this part 0. And so this one is scalar matrix, it's called. It's okay. So look at the first example, this one. This one is square, yes. Diagonal, diagonal, yes. And this one is scalar, not scalar, because look at the main diagonal entries. -1 is different from 1, and 0 and 2. It's okay? So this one is not scalar. Look at the next one. This one is a scalar matrix, and it should be diagonal. Diagonal, and yes, this one is square and diagonal, yes. And the entries 0 is equal 0. Main diagonal entries, the same. So this one is a scalar matrix, this matrix, and also square, diagonal, and also scalar. Look at this one. This one is a scalar, yes. What's the scalar here? 1. It's okay. Main diagonal entry is 1, 1, 1. So this one is scalar matrix. It's okay. Any question? No. Okay. So, and also if the matrix and but omit and this part now. Look at this one. This one is a scalar matrix. This one is a scalar matrix. It's okay. So, and take the 0 matrix. What's the 0 matrix? And the 0 matrix means and all entries 0. It's okay. Look at this one. Sorry. Look at this one. This one is 0 matrix. It's called 0 matrix because all entries 0. This one is not 0 matrix. It's okay. So this one is called identity matrix. Identity matrix means should be diagonal. It should be scalar matrix, and the scalar should be 1. This one is the identity matrix. It's okay. Identity matrix, and this matrix is denoted by this notation I, because identity matrix used and this the identity. What's the dimension? And the dimension 3 by 3. So right here sub 3. It's okay. So for example, this one A sub 2. What does it mean? This one is identity matrix. So this one dimension 2 by 2. So this one is 1, 0, 0, 1. It's okay. So this one is identity matrix but dimension 2, and here this one is identity matrix but dimension 3 is not equal. It's okay. A sub 3 is A sub 2, not the same. It's okay. Different from identity and A sub 3. It's okay because dimension not the same. 2. For example, A sub 4, 1, 0, 0, 0, 0, 1, 0, 0. This matrix, another identity matrix, okay? A sub 4. Yes, and the diagonal matrix, identity matrix, A sub I A sub I should be 1. It's okay. This one is identity matrix. So, what can you say about the identity matrix, scalar matrix or not? Scalar matrix is okay because scalar matrix should be and is used and the main diagonal entry should be a scalar, the same 1 1 1. So identity matrix is the scalar matrix. Identity matrix is scalar matrix. And also, zero matrix is a scalar matrix or not?
Yes.
Yes. It is true, yes, in the scalar matrix. Everybody, it's true. Any zero matrix is a scalar matrix. It's true.
No.
If your answer is no, what's the reason?
Because zero matrices can be not square matrix, so it can't be scalar matrix for all.
Yes, you are right. And this because look at this example, this one. This one is a zero matrix or not? Zero matrix means all entries should be 0 0 0. Yes, satisfy. And so this matrix is a zero matrix. Zero matrix, but dimension 3 by 4, not square. So, and not square, it means this one, it is not possible to say the scalar matrix, because scalar matrix and if our matrix, scalar matrix, first condition should be square, but not square. This one is zero matrix 3 by 4, not scalar. Not scalar. Look at this one. This one. This one is zero matrix, but dimension 2 by 2 scalar matrix. So, but this one is scalar, and this one is not scalar. So, and this statement, it is not true always. It's okay. This one, and sorry, not this one. And sorry. This one is true. Every identity matrix is a scalar matrix. It's okay, it's true. But and the zero matrix is a scalar matrix. Scalar matrix. It is not true, false. Because what is the reason? Let's give a counter example. This one. This one is zero matrix, but not scalar. It's okay? So, natural question. And now, take any scalar matrix. It's okay. For example, A. A is a scalar matrix. A is scalar matrix, so A is, what can you say about the A? A is a diagonal matrix or not?
Yes,
Yes.
diagonal.
So we can say that every scalar matrix is a diagonal matrix. It's true?
True.
Yes. A scalar matrix this one is a diagonal. Every diagonal matrix is a square matrix. It's true or not? every diagonal matrix is a square matrix?
Yes, true.
Yes.
Yes, it is.
Yes. So, and this one is a square matrix. It's okay, everybody? And then the natural question, take every square matrix is a diagonal matrix. It is true. Every
No.
square matrix is a diagonal matrix.
No.
No, because let's come back and the example. It's okay. This one, square matrix, but not diagonal. It's okay. So let's come back our statement. This one, and this direction, it is not true. It's okay. So let's. This one is true. Every diagonal matrix is a scalar matrix. This direction, it is true. Every diagonal matrix scalar matrix?
No.
No, because look at the this one, diagonal matrix, but not scalar. It's okay? So, and this one is not true. It's okay?
Hocam, peki birebirlik matrisler için diagonal ya da scalar bahsi geçebilir mi, yoksa yorum yapılamaz mı diyoruz?
Yani çok özel durumu onlar. Onlar özel
Tamam
durumu
hocam.
sağlıyor mu? Sağlıyor. Ama reel sayılara karşılık geliyor zaten. Özel durumlar onlar. Ama bu dediğimiz her şey bütün boyutlardaki matrisler için geçerli. And these statements are true and for all matrices. It's okay? All matrices. If our matrix is a scalar, yes, diagonal and also square. If take the square, it is a diagonal and also scalar matrix. It's okay? This one is general case and means matrix and the m by n matrix and the m by n. It's okay? And this one is true for all m by n means take the special matrix, of course, satisfied under this direction. For example, square matrix is a diagonal. Take this one, 2, 0, 0. This one is square and also diagonal. But this one is the special matrix. But take any square matrix, 1, 2, 3, 0. This one is square but not diagonal. Gives only one and the counter example. So it is not possible to say that this one it's not true. It's okay. Yani verdiğiniz bunlar doğru mu dediğimizde always, her zaman doğru olması gerekir. Yani bir tane örnek sağlıyorsa bütün matrislerde sağlıyor diyemiyoruz. Tamam.
Tamam hocam.
Bu matrislerin, yani eğer bu statement'lar doğru demeniz size bağlı değil. İstediğiniz matrisin boyutlarını seçin, tüm MN matrisler için sağlıyor. Bir tanesi için sağlıyorsa bütün matrisler için sağlamasını gerektirmez. Counter example verirsiniz. Mesela burada niçin square matrix diagonal değil dedik? Çünkü bir tane örnek verebilirim. İşte buradaki örnek. Bitti. Bir tane örnek vermeniz yeterli. Square but not and the diagonal. So, and this statement, it's not true. It's okay? So, write this one. If and take any statement and determine whether, for example, and the question is, and determine whether the following statement is true or not. If and false, and gives a counter example. It's okay? But if and true, and prove that. It's okay? Yes, and now I think it will be better, and let's have a break and 10 minutes. It's okay? And then we will continue. It's okay? Let's stop here now.